All right, subscribers, welcome back to another episode of Science with Surback. Today we're talking about section 8.4, which deals with the metallic bonds and properties of metals. The objectives for this lesson are to describe a metallic bond, explain the physical properties of metals in terms of metallic bonds, and define and describe alloys. Okay? So we get started here with our basis of metallic bonds. Previously, we talked about crystal lattices, which was that three-dimensional structure that ionic compounds had, and they formed those 3D shapes because of the different ions that were involved in those ionic bonds. Now, metallic lattices here, the big difference you see is they consist of 8 to 12 other metal atoms that are surrounded by other atoms. So what happens here, if we take a look down here at the picture, we get atoms really closely together. And so what happens is this. They form that very similar pattern that ionic crystal lattices do, but there are some differences, okay? So metals in a metallic bond are not bonded ionically. What that means is that they have electrons that are not given from one atom to another. Remember, all of those atoms in here, all of these positive charges are the same metal, okay? What happens here is this. Because they don't give their electrons away, they do not form a positive charge, but they form this sea of electrons, okay? And so what happens here is that because they look very similar to our ionic compounds, they are going to have many properties. So let's go ahead, let's learn some terms, and then we will be able to understand metallic bonds a little bit more. Shall we shift into here to what an actual metallic bond is? So it's defined as the attraction of metallic cation, positive ion, with delocalized electrons. All right, so that delocalized electrons, that should be a new term, and we describe that next. So for a metal, these are electrons in the outer energy level, like a valence electron, that participate in bonding of metallic atoms. The big difference between an ionic crystal lattice and a metallic lattice is that these electrons, these delocalized electrons, can move around easily in what we call the sea of electrons. So what this picture is showing is that we have the positive red spheres representing the nuclei of the metal atoms in the metallic bond. And then these electrons, they are free to roam around that outer energy level of the surrounding atoms. So essentially what happens here is we get atoms that are so close together that these electrons can be transferred, or transfer is not a good word, but they can move from one atom to another very easily because those metal atoms are going to overlap. Now, because you have these electrons that can move around fairly easily from one atom to another, we get a lot of those metal properties that we can describe and now have more details about. Okay, so because of the metallic bonding and because those electrons are delocalized, they move around in that sea of electrons, they account for many of the properties. So some of the properties here that we talk about is melting points. Most of the time, our metals are going to have a variety of melting points. There is not going to be a definite melting point or a extreme melting point, but for the most part, they have high melting points because we still have a lot of positive portions, positive nuclei, surrounded by a lot of those electrons, all right? Our boiling points, you can see they're much more extreme and require a lot more energy to separate those atoms. Think about this. You have a group of people. If you had a group of people, it's a lot harder to separate that group of people than it is to separate just two people. Well, again, that's all accounting for that metallic bond. Now, our other properties, we've seen these properties before of metals when we described metals on the periodic table, but we have our properties here. Now, I want to bring up a point here. Good conductors, meaning they can conduct electricity very easily. Good conductors of electricity, the reason that metallic bonds do that is because they can have those sea of electrons, all right? Now, again, our properties, all these properties that a metal or metallic bond has is because of those electron sea, or those electrons that are free to roam around between one atom and another atom. And we call those electrons delocalized electrons. All right, so now that we have some of these properties identified for metals, we can begin to talk about what we can do with some certain metals, okay? So one term that comes to mind here, or one term that we'll talk about, is an alloy. Now, I'm sure you heard of an alloy, whether it's on a car commercial or an advertisement of sort, because alloys, pretty much anything metal, or majority of things of metal, are going to be an alloy of metal when you buy it from the store. And that's a mixture of different elements with metallic properties. These properties are going to differ than the elements themselves. So a great example of this is steel, right? The main component in steel is going to be iron, but you're also going to have some mix of other elements, and most of the time that's used to strengthen that iron or provide some properties of that iron, such as the ability not to rust. So what they'll do is they coat that iron in, they call it stainless steel. They coat that iron with another metal and they produce that alloy. Okay. Another good example of a alloy is brass. Okay. So brass is a combination of brass is a combination of two metals here. Same thing with bronze. Bronze is not an element. It's a combo of elements, okay? So we get to our final portion here that talks about our different types of alloys, all right? So the first type of alloy we have is a substitutional alloy, okay? So substitute, if we take that word there, we can break it down. We're going to substitute one metal for another metal in a sample, okay? So again, we replace one metal with another metal. A great example of this is sterling silver. Now, sterling silver, how they make it is they start out with pure silver, and then they add or they replace those silver atoms with another metal. Most of the time it's copper, so that copper replaces that silver, and that's how sterling silver is produced. Now, the other type of alloy that we talk about here is interstitial alloys. And so what happens here is that, remember, in our metallic bonds, we had those delocalized electrons floating around in that sea. And so what happens here is you create these spaces, or you kind of have these voids between atoms and between those electrons that move around from one place to another. And so what happens is they can insert smaller atoms into those spaces or crevices that are created because of these atoms. And so we get here carbon steel. So these pipes here are carbon steel, and so essentially they're taking carbon atoms and they are inserting them into those areas, into those voids that you have with metallic bonds. All right, hope you have enjoyed this particular episode, and if you haven't done so already, make sure you subscribe.